Okay, on this section of our course on algebra, we're going to talk about the properties of real numbers. Now, you'll be happy to know that in this section we start what I really consider to be algebra. The next section we'll actually start dealing with equations, but this section we actually get to start talking about some really cool properties of math. It's some of the stuff that can be that can look confusing, but in actuality they're very, very, very simple if you have it explained properly, and that's what I'm going to hope to do to you today. For you today. So these are the properties of real numbers. Okay, I'm going to go through the kind of the theory, which is going to be real quick because I typically don't like to do theory, but it's important for this section. And then we're going to blaze through a ton of examples, which are going to really help solidify everything, and shouldn't be any questions. Okay, there are these things called the closure properties. I don't even know why they call them closure, to be honest with you. But pretty much all you need to know, if A and B, are real numbers, and you can look back to the definition of real numbers, in the other lecture, but pretty much just consider them numbers. Okay, negative, positive, they're just not complex, but they're pretty much anything else. They're just numbers. A and B are numbers. If A and B are real numbers, then the sum of A and B is also real. I mean, it's kind of stupid when you think about it. If in the example there is if 1 is a real number and 3 is a real number, then the sum of 1 and 3 is a number, which is 4 in this case. That's also real. I mean, it's common sense. You know this already. It's not really anything that you haven't seen before. It's just you have to get used to seeing it in terms of this. So this is a property. Also, A minus B is real. Okay. A times B is real. And A divided by B is also, big surprise, real. Now let's think about this for a second. All this is telling us is I've got two numbers. I can add them, I can subtract them, I can multiply them, and I can divide them, and every time I do that I'm going to get another real number. And all that means is the number's not going to be complex, which means involves I. Okay, it's going to be a real number, which you've learned by plugging in your calculator time and time again. That 3 plus 4 is 7, and so on and so forth. Not really that big of a surprise. Okay, so those are called the closure properties, and the only reason I'm really defining them so rigorously, honestly, is in case you're testing on it. You're not going to really, I've done algebra for a long time. I've gone through calculus, differential equations, advanced mathematics, all kinds of things. You really don't need, unless you're going to be a math major, you really don't need to know this stuff too well, to be truthful. But you can be tested on it, and you're going to be expected to know it, and so I think it's important to know it. What else do we have? We have these things called commutative properties. These things used to confuse me because the word's so confusing. Here's what a commutative property is. Again, A and B are real, which just means that they're numbers, that they're not complex. If this is true, then A plus B is equal to B plus A. Think about that for a second. All it means is it doesn't matter the order in which I add numbers. 3 plus 7 is equal to 7 plus 3. Big surprise. You already knew that. 3 plus 7 is equal to 7 plus 3. Okay, great. This is just proving it for you, or not really even proving it, just telling you that it's true in all cases. Also, A times B is the same as B times A. And you learn this in your third grade multiplication tables. 7 times 6 is equal to 6 times 7. This is just laying it out in all of its glory, showing you that it's true in all cases. Those are the commutative properties. But you will probably be asked somewhere on a test, tell me what a commutative property is, and then you can go ahead and do that. Okay. Then there are these things called associative properties. And again, if A and B are real, then, and this is kind of cool, A plus B plus C is equal to A plus B plus C. And you know, this looks complicated, but it really isn't. Remember, parentheses tell me I'm going to do this operation first. So in this case, I'm going to add A and B and then get the answer and add it to C. In this case, I'm going to add B and C, and I'm going to get that answer and add it to A. And all this is telling me is that it doesn't really matter how I do the addition. Addition, it doesn't matter if I add 3 plus 4 plus 7, or 4 plus 3 plus 7, or 7 plus 4 plus 3. It really doesn't matter. I'm always going to get the same answer. That's why they're equal. And that's the associative property of addition. Associative property of multiplication looks something like this. A times B times C is equal to A times B times C. Same thing. 3 times 4 times 7 is equal to 7 times 3 times 4. I mean, you can juxtapose the numbers however you want to do it, but multiplication and addition, the order does not matter. That's really all that's saying in terms of English. So if you can remember that, associative and commutative, pretty much all it means is the order doesn't really much matter. And it's just kind of laying that out as a fundamental rule of algebra for you. Now here's a really cool and extremely useful property. If you have to memorize or learn anything, learn this one. This is the distributive property. Okay, distributive, very, very important. We're going to use this time and time and time and time and time again. This is the most useful thing in this whole section. A times B plus C is equal to AB plus AC. That's it. That's all you have to memorize. And really, what you need to kind of condition yourself to be aware of is anytime you see a number or a letter outside of parentheses and something in here that has like an addition or a subtraction or something, this is the same thing as multiplying whatever's outside in, and that's one term, A times B, plus, and then over here to the other term, A times C. This is implicitly what's going on, and let's just do something just to prove it to ourselves. Let's say A is equal to 2, B is equal to 1, C is equal to 3. Very simple numbers, okay? A times B plus C is equal to A is 2, B is 1, C is 3. 1 plus 3 is 4, so that's 2 times 4 is 8. Okay, so according to doing it this way, the answer is 8. Now let's do it this way. A is 2, B is 1. A is 2, C is 3. 2 times 1 is 2, 2 times 3 is 6, 2 plus 6 is 8. Okay? I'm just proving it to you with numbers, but you shouldn't even have to use numbers as we go forward with the algebra, because A parentheses B plus C is equal to A times B plus A times C. If there were a minus here, it would be a minus here. That's called the distributive property. Extremely useful. We are going to become very, very comfortable with the distributive property because we're going to use it pretty much from here on out. As soon as we start dealing with equations, anytime there's parentheses, anytime you simplify, we're going to use it in factoring, we're going to use it in all kinds of things. So if you learn anything out of this section, learn that. That would be my advice to you. Alright, I'm going to talk a little bit about identity elements. These are simple, but they can be kind of complicated. For addition, identity, the identity number is 0. What the heck does that mean? All it means is 3 plus 0 is equal to 3. In more general terms, A plus 0 is equal to A. All it means is for addition, the identity is 0, meaning I can add 0 to whatever it is and I end up with where I started. So it's an identity. I don't change anything. It's just a magic number. I can add or subtract it. It doesn't really change anything. Again, this is just an algebraic definition. Is it really important? I don't know. You decide. You may be asked that kind of thing on a test. The identity number for multiplication and also for division is 1. That's the magic identity number for multiplication. Why? Because a times 1 is equal to a. In numbers, 2 times 1 is equal to 2. It's the magic number that I use to multiply, and I end up where I started. That's why it's an identity. Okay? And there's one more thing I want to go over before we actually work a lot of problems. And this is actually quite important. This is the second most important thing in this section. And that's the inverses. I want you to pay attention to this. I'm trying to cut to the chase and tell you what you really need to pay attention to, and these two things I think are important. How do I say this? The inverse of addition is subtraction. That sounds simple. What does it mean? Well, if I have, let me just write it down. A minus A is equal to 0. That's a very simple statement. But A, how do I say this? If I have, like, let me just give you, let me choose a different example actually. Let's say A plus 1 is equal to 2. Okay? And I want to get A by itself. I'm going to need to do the inverse of addition here because I've got addition going on. Okay? But let's say I want to solve for A. We're going to do a lot of this in the next section, but it's not too early to start now. If I want to get A by itself, I've got to do the inverse to this side of the equation, and because it's an equation, I've got to do the inverse to the other side. The inverse of addition is subtraction. So I can say A plus 1 minus 1 equals 2 minus 1. All I've done is subtract 1 from both sides. And because it's the inverse of addition, 1 minus 1 gives me 0. So then I'm left with A is equal to 2 minus 1, which is 1. And basically I had to recognize that I had addition going on here, and so I had to do the opposite, which was subtraction. Go ahead and subtract whatever's left over here, and then I can get rid of it, because 1 minus 1 is 0, 10 minus 10 is 0, etc., etc. So the inverse of addition is subtraction, and that's the reason why. Because you can use that fact to kind of get things on your side, so to speak. Okay. Now I want to go ahead and work some problems. And we've already done a good bit of the work in the actual text, so we're not going to work a huge amount of problems, but there are a couple of cool things that I want to do in terms of problems. I want to work with the distributive property a whole lot because I already said that was very, very important. So we're gonna work at least 3, 4, 5 problems on the distributive property by itself. So let me just go ahead and get started. Let's say we have 3 times x plus y. Remember, I said anytime you see a number or a letter or something sitting outside of a parentheses with something going on in here, like an addition or subtraction, you need to start thinking distributive property. So for these problems here, what I want to do is I want to expand this thing using the distributive property. If you flip back or rewind or go in your textbook or whatever and look it up, the distributive property basically means that I multiply 3 by the first thing, and then I add that to the multiplication or the product of 3 times the second thing. So in this case, to actually expand this, it's going to be 3x, that's this times the first one, plus, because I've got a plus here, 3 times the second thing. These two things are exactly equivalent to one another. I can take numbers and plug them in just like we did before, and they will equal each other. Okay? Let's pick another example. Let's say I've got x times x plus 3. Again, this times the first thing is x times x plus this times the second thing, which is x times 3, which is 3x. I can write it in reverse order. That's the same thing. And this is equal to x times x is simply x squared. Remember, the square means x times x plus 3x. And that's the answer. So we're using the distributive property to actually expand this out. So it's quite simple. You just need to remember multiply times the first, multiply times the second, add them together. Okay? Let's say we've got negative x times a plus b. Now I've got to take the whole thing. Remember, minus x times a. This is going to be minus xa. And then I'm going to have to multiply times the second thing. Now, watch how I do this here. I'm not going to skip any steps. I'm going to carry the plus because plus is already there. And I'm going to use parentheses here to be clear. Minus x times b. I've carried the plus from here and I've used the minus x here. Now this is simply equal to minus xa plus a negative we learned from before is just minus xb. As you get more proficient with this, you will start to realize that doing this second multiplication, minus x times b, you will just start to be able to go straight to the second step. But in the beginning, do it very mechanically and then simplify, and I think you'll have less chance for errors. If there's one thing that I can say about algebra, don't skip any steps, especially early on when you're still learning how to do it. You know, just as time goes on, you'll get comfortable with maybe you know, putting a few steps kind of by the wayside, but don't do that early on. Okay, let's say I have something like 4 times x squared plus x. Okay, this times the first thing is 4x squared, and this times the second thing, got to put a plus because I got a plus, 4x. Now notice we didn't do anything special with this x squared. All we're doing is writing 4 times x squared. We're not changing anything. We're just showing that it's multiplied plus 4x. And those are exactly equivalent. We're using the distributive property here. What if I have minus 5 times t plus 2 equals minus 5 multiplied into the first thing is minus 5t plus, because I have a plus here, minus 5 multiplied into the second thing, 5t times 2, and this is going to equal to minus 5t plus a negative, just means minus. 2 times 5 is 10, 10t. Now when I have some numbers here, I can go ahead and do the multiplication. That's why I did that. So plus a negative gives me the negative here. 2 times 5 is 10, and I just carry the t down. That is the answer. Now let's say I have minus 2a times x plus a. This whole term multiplied into the first thing is minus 2ax plus, because I have a plus here, and then this multiplied here is minus 2a times a, okay, which is minus 2ax plus a negative gives me just a negative 2, and then a times a is simply a squared, and that's the answer. So it's not too bad when you really get down to the nitty-gritty of it. Distributive property, as I said 3 or 4 or 5 times, I'm trying to drill it in, is extremely useful. You will be using that thing all throughout algebra, so I consider that the bread and butter of this particular section. And that's all my opinion. I think if you talk to a math person, a straight math person, that they would probably say it's all important, but I think some things are more important than others. Let's go ahead and do another quick exercise. I'm going to write some things on the board, and then we're going to talk about what property was used to do the simplification here. So let's say 3 plus x equals x plus 3. Well, if you stare at that, and if you look back in your textbook, you'll realize that that is the commutative property. As that commutative property was a plus b is equal to b plus a. So that's commutative. I'm just going to write com there, commutative. And what if I have x times y equals y times x? Again, that's the commutative property. It's just the commutative property of multiplication instead of addition. Commutative means you can reverse the order. Okay? And if you don't remember that, just go back to the notes or to the textbook or to the other part of the video and you'll see. What if I have negative 2 times x plus 3 equals minus 2x plus minus 2 times 3? What property did we use to simplify it this way? Well, that's simply the distributive property, which is what we've been working on most of the time. Anytime you see these parentheses and multiplication in, good chance distributive. What if I have x plus y plus z equals z plus x plus y? Well, this is going to be the associative property of addition. Associative property of addition. Associative means you can flip the order around when in groups of 3 like this, and in addition, and you get the same answer. In multiplication, it works the same way. So those are just a few quick examples, kind of twisting it around a slightly different way to kind of explain, kind of get it across. Okay, and let's just do a couple of additionals. 5 times 1 is equal to 5. And what property did we talk about that rings true of this? This is the identity. Identity of multiplication, in fact, is 1. So that's what was used there. And what about 3 plus minus 3 equals 0? Well, this is the identity of addition, meaning that the opposite of addition is subtraction, so that's kind of the identity there. Okay. Final type of problem we're going to do in this section is I'm going to write something down, 3x plus 2, and I'm going to tell you how to simplify it, and then we need to use that property to go ahead and simplify it. Let's use the distributive property here. Distributive. 3 times x is 3x plus 3 times 2 is 6. That is the answer using the distributive property. What if I have y squared x and I want to use the commutative property? Commutative means you can flip the order. So that's simply equal to xy squared. Excuse me. And finally, what if I have x plus y times z and I want to use the commutative property? Remember, this whole term is multiplied by this whole term. Commutative means switch the order. So if I want to use commutative to rewrite this, it's just going to be equal to z times x plus y. Because this is a term and this is a term, and I can flip the order, and that's commutative property. Okay. And what if I have x plus y and I want to use the commutative? I can flip the order, so it's equal to y plus x. And what if I have x plus y plus z and I want to use the associative? Okay, that's the one where I can move the parentheses around any which way I want, and it doesn't matter. I can add these in any order. So if I want to use this to rewrite it, I can do it as x plus y plus z. It doesn't matter. I'm just doing the addition, so I can do it in any order. That's the associative property. And then finally, to beat it down to death, x times y plus z using the distributive property is simply going to be equal to xy plus xz. xy plus xz. And that is pretty much all I wanted to cover in the properties of real numbers. I hope I've made it a little bit clearer to you. It's really not that hard. You just need to learn the basic few properties, and some of these things are going to be used all throughout algebra, I promise, and you'll be well served to learn them, especially the distributive property and those identities, as we will use those things as we go along. The others are nice to know for tests, but to be truthful, you're not going to really need to know them all that terribly much. But I thought I'd include them for completeness. And that's it.